Okay, here we go. We're going to do Polly Pocket tutorial number 3. We're going to revisit distributive property with some things that look familiar. For number 1, we're distributing the 3. 3 times 2x is 6x. 3 times 5 is 15. We did this first semester when we were solving equations. You even did this in middle school. So far, it's just a review. 4 times 3x is 12x. 4 times negative 7 is negative 28. And now here we see something a little bit different. We haven't distributed in algebra, at least. You might have done it in middle school, but we haven't distributed a 2x to a 5x. So when we do 2x times 5x, we're going to remind ourselves something. A 2x times a 5x. We know that 2 times 5 is going to give us 10, right? But what does x times x give us? X times x gives us x squared. That 2 represents the fact that we have 2 x's being multiplied together. So 2x times 5x is equal to, I don't need to put an equal to sign, but that's the same thing as writing 10x. And then we know 2x times negative 3 is negative 6. 2x times 5x is 10x squared, just like we did over there. And then 2x times negative 3 is negative 6x. Okay, when we move to our next problem, I'm going to let this be our little working out area over here. When we move to our next problem, we've got 4x squared times 2x cubed. So we've got 4x squared times 2x cubed. Can't really see that with this green, so let me go back to the blue. We know 4 times 2 is 8. When we look here, we've got x squared times x cubed. X squared is x times x, right? X cubed is x times x times x. So how many x's do I have altogether? 1, 2, 3, 4, 5. So I'm going to write that as x to the 5th. And a shortcut to do that is this. Because x to the 5th means that we're taking 5 x's and we're multiplying them. When a shortcut would be, though, when we see that we're multiplying the same base times each other that's raised to an exponent, we can just add those exponents together. I believe that you knew that rule from middle school, but just to make sure, we're going to revisit that. So 4 times 2 is 8, and x squared times x cubed is x to the 5th. Okay, here when we have 4x squared times 5x, let's go back over here to the drawing board and make sure we're okay with this. If we have 4x squared times 5x, we know that 4 times 5 is 20, and x squared is the same thing as writing x times x, and times this other x over here. So we'll have, how many x's are we multiplying together? 3 x's. So we say x to the 3rd. The shortcut is this. Same base, right? This is 2 as the exponent. This exponent, we don't see it. And when we don't see an exponent, it's because it is 1. So 2 plus 1 is 3. So that's why when we come over here, we've got 20x to the 3rd. All right, and then when we say 4x squared times negative 1, 4 times negative 1 is negative 4. And I'm going to have to move this. It's really getting in the way of our answer. That's negative 4. And then the x squared comes along for the ride. Don't forget about that x squared. All right, here's something that looks a little bit different. What we want to distribute is on the right side instead of the left. We've seen this before. We can do this. We're still going to distribute 2x times 5x. We know 2 times 5 is 10. X times x is x squared. And then we're going to go ahead and distribute 2x times negative 1. 2x times negative 1 is negative 2x. And here we go. Back to where we've got to think about our numbers and our exponents. We have 8x to the 4th times negative 3x to the 3rd. First I do my numbers. 8 times negative 3 is negative 24. And then I think about my exponents. If I have x to the 4th and I have times x to the 3rd, same base, I'm going to add my exponents. So I've got x to the 7th. Then when I distribute again, I've got 8x to the 4th times x squared. So I've got 8 times a 1, even though you don't see it, there's a 1 there. 8 times 1 is 8. And then we have x to the 4th times x squared. So x to the 4th times x squared at same base. So I add my exponents, the x to the 6th. And then when we distribute our last one, 8x to the 4 times 4, well, 8 times 4 is 32. And don't forget that x to the 4th comes along for the ride. Okay, a lot of times people will miss these problems on the test because when there's not, see how with this 4, it's just plain old 4. There's no other exponents here, or there's no x raised to an exponent. And then people forget all about x to the 4th. Well, that's still part of our answer. All right, do you want to know why? I'm going to tell you why. Because if there's no variable there, there's no x there, it's because it was raised to the 0 power. And anyways, you know what, you're going to see in tutorial 6, we go over all these exponent rules, including this one, and you'll get a little bit more of a in-depth understanding of it. For now, just remember, it comes along for the ride. All right, let's change up our colors. Negative 4x squared times 12x to the 5th. Negative 4 times 12 is negative 48. And x squared times x to the 5th, same base. We're going to add our powers. So that's going to be x to the 7th. All right. Then we're going to distribute again. Negative 4x squared times negative 10. Well, negative 4 times negative 10 is a positive 40. And x squared comes along for the ride. All right. And finally, the last one, negative 5x times 5x squared. Negative 5 times 5 is 25. Negative 25, rather. And x times x squared, if I do that down here. Remember, we don't see an exponent, but that exponent really is 1. So 1 plus 2 is 3, so that's x to the 3rd power. Then we're going to go ahead and say negative 5x times 7x. That's going to be negative 35. And we're going to have x times x. Remember, they're the first powers for both of them, so that's x squared. And then we'll have negative 5x times negative 2. Well, negative 5 times negative 2 is positive 10, and the x comes along for the ride. So right now, we're not solving equations. We are just having fun with math. We are distributing, becoming good distributors. So down the road, when we're doing more difficult math and distributed property is part of the more difficult problem, we are going to be so good at this part. All right. Write an expression to model the area of the figure. So the area is always going to be length times width, or we can say width times length. The point is we're going to multiply one dimension times the other. So when I look at this, I'd like to set it up as 2x times 3x minus 7. And we're just going to take it a step further, and we're going to distribute 2x times 3x. Well, 2 times 3 is 6. X times x is x squared. That x squared reminds us of how many x's we're multiplying together. X squared means x times x. All right, and then 2x times negative 7 is negative 14x. That, my dear ones, is our answer. I know that usually when we're finding the area of something, it's 30 square feet or 1,000 square centimeters, 1,000 centimeters squared, however you want to say it. But no, we have our area for this figure is 6x squared minus 14x. All right, and that's it for that one. We're just repeating the same thing. This one would be 3x times 5x minus 12. We're going to distribute. We'll get what? 15x squared. We'll distribute again, and we'll get negative 36x. That is our answer. That's where we'll stop. And that's it. So thanks for joining me for tutorial 3 with this Polly Packet. And I'll see you, I'll see you in class. Like, I'll see you right now in just a second. But I will also see you in Polly Packet tutorial number 4. Thanks for joining me.